In Unit 5, the last topic is Unified Power Quality Conditioner, which is called UPQC. So the UPQC consists shunt active power filter and series active power filter. So this is a source side, this is a non-linear load is present in load side. So what are the disadvantage of non-linear load is, so the non-linear load always produces a harmonics, and also there is more deviation in the voltage drops. So the voltage drop is not constant. The voltage drop is increases or decreases abnormally. So this can be compensated by using UPQC only. So UPQC also used in distribution network. So there is a two filters, shunt active power filter, series active power filter. Series active power filter is improve the stability. Shunt active power filter is maintain the voltage profiles. There is a series transformer is used for injecting the voltages. So the operation is, whenever the non-linear load compensating voltage, how can the voltage is compensate means, so the voltage is taken the shunt active power filter by using gate pulses that can be operated by using there is number of techniques are there: pulse width modulation, sinusoidal pulse width modulation, space vector modulation is there. In these three techniques, we using any one for operating the filter circuit, active power filter circuit. So the DC link is used for stores energy, that will stores the energy. The series active power filter also by using the pulse width modulation, that will also operated. If there is a 6 switches, the 6 switches not turned on at a time, that will be turned on simultaneously, upper portion from one, lower portion from one. At a time only 2 switches will be turned on. In a 12 switches, there is a mainly 2 to 4 switches is turned on at a time. So that means the switching losses is reduced by using this UPQC. So this turned on, so how much the voltage we needed, based on that voltages the series active power filter is turned on. So UPQC used to mitigate the power quality problem like harmonics and sag. The shunt and series active filter performs the simultaneous elimination of current and voltage problems. The power fed is linked through common DC link and maintain constant real power exchange. The DC link is connected through the reactor. Power quality problems are harmonics, sag and swell, which are mitigated by the active filters by the configuration of dynamic voltage restorer DVR, distribution static synchronous compensator DSTATCOM, and unified power quality conditioner UPQC. Unified power quality conditioner for non-linear and voltage sensitive load has following facilities. It reduces the harmonics in the supply current so that it can improve utility current quality for non-linear loads. UPQC provides VAR, volt amp reactive requirement of the load, so that the supply voltage and current always in pace. Therefore, no additional power factor correction equipment is required. This also used to improve the power factor correction. UPQC maintain load end voltage at the rated value even in the presence of supply voltage sag. Series active power filter. It compensates current system distortion caused by non-linear loads. The high impedance imposed by the series active power filter is created by generating a voltage of the same frequency as that of harmonic component that needs to be eliminated. It acts as a controlled voltage source and can compensate all voltage related problems such as voltage harmonics, voltage sags and swells, voltage flickers, etc. Shunt active pop filter. It compensates current harmonics by injecting equal but opposite harmonic compensating current. It operates as a current source injecting the harmonic components generated by the load but phase shifted by 180 degrees. They are usually connected across the load to compensate for all current related problems such as reactive power compensation, power factor correction, current harmonics and load unbalance compensation. The unified power quality conditioner combines shunt active power filter with the series active power filter sharing the same DC link in order to compensate both voltages and currents so that the load voltage become sinusoidal and at normal value and the source currents become sinusoidal and in phase with the source voltages. A UPQC is a device that is similar in construction to UPFC. The UPFQC, just as an UPFC, employs two voltage source inverters that are connected to a DC energy storage capacitor. One of these two VSI voltage source inverters is connected in series with the AC line while the other is connected in shunt with the AC system. A UPQC that combines the operations of a distribution static compensator and dynamic voltage restorer together. A UPQC is employed in power transmission system to perform shunt and series compensation. At the same time, a power distribution system may contain unbalanced distribution and even DC components. Therefore, a UPQC operates better than UPFC with all these aspects in order to provide shunt or series compensation. The UPQC is a relatively new device and not much work has yet been reported on it. So this is a schematic diagram of UPQC compensated system. Two alternate connections. A UPQC combines a series and shunt compensator together. It can therefore yield the benefits of both these devices. For example, it can tightly regulate the load bus voltage V shown in figure A. Therefore, all loads including the unbalanced and non-linear load will have a supply voltage that is unbalanced and sinusoidal. The UPQC can also make the current drawn from the supply balanced, sinusoidal and in phase with the terminal voltage. Therefore, the voltage of any bus upstream from the point of common coupling will not be affected due to a non-linear and unbalanced load. However, it will be impossible to correct the unbalance and distortion produced by the source voltage using this device. Therefore, the upstream bus voltage will remain unbalanced and distorted. There are two different ways of connecting a UPQC. In the connection of figure B, the series device is placed before the shunt device while it is placed after the shunt device in figure C. The dotted line in these figures indicates any energy exchange path between the devices. In a UPQC, both the shunt and series inverters are supplied a common DC capacitor used in bulk power transmission. The energy exchange between the series and shunt device takes place through common DC capacitor. This is the working of UPQC.